Hello. Today I am back with another Fog of War Sudoku. So, yeah, and I found at least a reliable source for me to find them for a good while, because I was just on Logic Master Germany earlier today, and I discovered that AstralSky has a series of at least 20 Fog of War Sudokus, so when I guess when I feel like doing some Fog of War Sudokus in the future, I'll just be able to jump back there. So yeah, alright. Anyways, with that being said, I'll have a link to the puzzle and also a link to the creator page in Logic Master Germany's in the description. And with that said, we'll just get right into it. So at least for this Sudoku, I essentially learn more of the rules as I go on. So I'll just hit start here, and since I have one circle, I get to know that box 2 is a magic square, and essentially a magic square is just a square where every row, column, and I'm assuming diagonal, since otherwise I don't see a way to get information here. Yeah, every row, column, and diagonal adds up to the same number. So since in Sudoku each box has digits 1 to 9, the total sum of the box is 45, which means every row, column, and diagonal should sum up to 15. And you can notice that the central digit here gets used in 4 different combinations, which I'm not going to do brute force proof here, but you can to determine that it must be a 5, and it lit up, which does confirm that, in fact, the diagonals are also being considered, since otherwise there isn't enough information to go off of. Anyways, 2 and 3 are now both visible, so let's see. There's a river that runs from the left edge to the right edge, which has a branch that touches itself diagonally. And there is at least one river cell orthogonally adjacent to this node. Every digit on the river must be consecutive to at least one of its neighbors on the river, and it does not enter this area. So one of these two, I'm going to guess the river is going to be blue. One of these two is blue. And, okay, I'm not sure if I can do anything about that yet, other than I know, since it doesn't go in this box and has to be orthogonal, that's why it had to be one of those two. Additionally, 3. The arrows function as checkpoints. The arrow circle must be orthogonally adjacent to exactly one. So, this cell here is adjacent to exactly one river cell, so one of these two is also a river. Digits on the arrow. I think this is just going to be an arrow Sudoku. And one cell sum. Let's see. Okay. Digits on an arrow, when read from circle to tip, including the circle, form a number which equals the sum of the digits on the river up to and including the cell where it borders the circle. One cell sum will only have one circle, so essentially, since there is no line coming off of this cell here indicates the entire sum of the river up until this point, which, if it's in the 4th row, well, there's only 2 options here, and I think I can determine which is valid. Let's, for instance, suppose the river is here. Then we need the river to get all the way to this column. Now, in order to do that, there's going to be a lot of variations. One thing that they... actually no, I was saying that, but this river right here is perfectly valid and gives me a 9 up here. But it's going to be... okay. So I actually think I'm going to have to think about this a little more. And sorry about the geese if they're popping up. There's just no escape from them no matter what time I film. So we're doing the middle of the night, but I can't really do that. So, yeah, they might pop up again, not sure. Okay, let's scan the rules a little more for this. Arrows can't be in a river cell. Form a number which equals the sum of the digits on the river up to and including the cell where it borders. So if this cell bordered, then this is one theoretically possible arrangement here that could work with a sum of 9, and I think it might actually be the only one, realistically. Okay, and if I am if this one is a circle, or this one's part of the river, then it's either going to have a pathway like this, in which case it's a minimum of 6, or a pathway like this is the only other one that could potentially be smaller, and that's also a minimum of 6 with 1, 2, 1, 2. Which either way means that this is 6, 7, 8, or 9, that's 1, 2, 3, or 4. And I don't think there's any restriction for 2, other than one of these two has to be part of the river. I guess I will consider what happens if this one is the river one. So I believe it said exactly 1. Now it's at least 1. So let's consider what happens if that's not part of the river, which for now I'll use green to mark not river. Then we're going to get something like this, and it's going to turn around somewhere back here. So I can mark that, and all of this. I believe, no, I cannot necessarily, it could do something like that. So I can at least mark these two, and all of this. Which doesn't branch or touch diagonally. Okay, so I actually don't think I can confirm that, because it could run along the edge like that and then go over. So it could also be here, it just can't be in this square. Yeah, because it could also run like that. Okay, so that makes this not as helpful of a deduction as I'd hoped. Okay, doesn't branch or touch diagonally. There's at least one river cell orthogonally adjacent. Every digit's consecutive to at least one neighbor. Okay, I mean, at this point, I think it has to have something to do with the 3. There isn't a doubt about that. Orthogonal to, well, this one's adjacent to exactly 1 at least. So, for this one at least, I can lock it into one of those two. Okay, digits on the arrow, when read from circle to tip, form a number which equals the sum of the digits on the river up to and including the cell where it borders the circle. One cell sum will have one circle, and arrows can't be in a river cell. Okay, let's see. I'm just going to consider this one again, because I already know if it's this one, then it has to be something like this. It's the only way I can see, right? Because, let's see. If it, for some reason, doesn't go this way, then it has to go like this. Which means I have 1, 2, 1, I have a minimum of 1, 2, 1, 2, 3. Or 1, 2, 1, 2, like 1, 2, 3, and 1 here. Which is already a minimum of 7. And I need to reach the edge somehow, which it can't go up or down really, because then it would be at least 8, and no matter how it reaches the end, then it would be over 9. So it would have to go like this, which also breaks for the same reason, which means that I'm guaranteed to have it go this way. Can't go there. And then if it doesn't go there, it has to go up here, in which case it's going to be in this box for at least one more cell, right, one of these two, and if it's in for only one more, then these 3 are a minimum of 6, and since I already defined it as being in for at least only one more, it would have to leave after that, but then there's no way it can reach the edge without using, since there would be a 1 here, or actually if it's vertical this is already 10, so it has to be in here for at least 4, which also breaks because the sum of 4 numbers is already 10. So now we have these 3, can't go one more because then minimum sum of 10, so it has to go either this way or this way. If it goes down here, then it's going to be in this box for 4 cells at least, which already breaks, so it has to go up. Then I have 6 here, minimum, 7 here, so in order to reach 9 or lower, I need to just immediately go to the end. So that is one possible path I can see, and then I would get all of this, and it would be a 9. So that's the possibility if it goes this way. And I will mark this possible lake in purple, and now we're going to consider this one. So either way, it's going to have to go here, right? Let's see. If this river doesn't flow here, then it flows in each of these directions, can't flow here. And then one of these two sides has to be the one that's approaching the far right column over here. If it is this side, then it has to continue along all the way over here, in which case it touches diagonally. So it can't be this side, it has to be this side, which means this side needs to reach the left column, which means it needs to go like that. That's obviously already too big. Therefore, the river has to go up, and it can't go here. But I do know for a fact now this square is in the river, I guess. Let's see what happens if this river cannot go this way now. Then it has to go up again, in which case it's going to be in this box for at least 4, so it's going to break this. Therefore, this square is also always in the river. Now, then this square can't be in the river in this case because it's going to hit the side here, which means that the river has to go here or here. If it goes up, it's going to be in this box for at least 4 again, so it's going to have to go over. And then this is a minimum of 6 for a sum. And these two need to be adjacent digits at least. Well, that's just guaranteed no matter which case we're in. And I think I can remove all of the other... I'm going to remove the purple here, and then I'll mark these 3 in orange as the other potential river path, because it's going to go one of these 2 paths now I've determined. So let's consider what possible digits I can have here. Considering the fact we know that this has to be... actually, this river could also potentially go here in the orange case, right? Because these ones sum up to a minimum of 6. So I could go all the way to here is possible. So I actually might want to consider if I can determine if that's the case or not. Because I'm pretty sure the river could run along the edge. So this one is a maximum of 9. Yeah, I guess it can reach maximum of 9 by potentially going down 2 squares. So I will mark that in, for now I'll mark that in gray to indicate that's not necessary, but it is possible. For this purple one, that's just simply not going to be the case because this is already the largest it could possibly get. Okay, and I can actually mark that one just as blue as well, since both of them hit it. Okay, so either way, if one of these two is, well, obviously I can't have a 5 amidst either of these, because then the 5 would have to be adjacent to at least a 4, which will break this no matter what. So the largest either of these 2 digits could be is a 4. And let's see. If one of these digits is a 4, then the other one's going to be a 3, and then there needs to be a 2, which, well, if there's a 4, then it's going to be 4, 3, and 2, and I'll have a 2 here. That's just the only way it can work, because this needs to be a 1-2 pair, and this needs to be a 1-2-3 triple in order for the purple path to be valid. And also, actually, for now I'm going to quickly pivot for a second and consider the magic square again, because realistically I can probably get more digits locked in knowing these 2 values, because the ones on the diagonals have to be in 3 valid sums, and the ones in the columns and rows are only in 2 valid sums each, or in these 4 boxes are in 2 valid sums each. Okay, let's see. So since this is a odd number, digits on opposite sides are always going to be the same parity, right? Because 2 odd sums up to an even and 2 even sums up to an even, and we're trying to get a sum of 15. So if these 2 were both odd, then these ones can share parity, and if both of them were even, then these would have to be opposite parities. Okay. So, actually, I think the more important question is, can I have a 9 on any of the diagonals? Because then if I had a 9, I would need to have 3 sets of, for instance, if this was a 9, I would need to have 3 sets of cells that add up to 6. And that's not possible, which means I can eliminate 9 from this. And actually eliminating that already eliminates the purple option just as an option for the island, because I can't get up to 9, which also means I can at least eliminate that cell from being possible for the boat path, because this was a setup here to get 9 as a sum with 1, 2 here and 1, 2, 3 here. Either way, let's continue with this. We know for a fact that 1, 9 is in one of these because it would obviously break otherwise from what I just described. And since I know I have a 1, let's suppose for instance that this is a 1, 9 pair here, right? Just to indicate it. Actually, I can, based on the fact that this is a minimum of 6, I can't have a 9 in here anyways because it would add up to 15 whichever way it went. So one of these two is a 9, one of these two is a 1. And if we have an odd in each of these, then these need to share a parity. And since that means all 4 of these are going to have to be the same parity, and the argument can be made either way. And since I already have 2 odds here, I know that I must have all 4 odds here. And yeah. Okay. So I probably knew at some point that that was just something you can brute force in Sudoku magic squares, but sometimes I guess it's good to get the proof in here. Okay. And I already deduced that. So let's see, can I have a 7 here in either of these? I can if this is a 6. Then it would be, actually, yeah, I can. 6, 7, 2 is a valid solution, and that is achievable, so I can't eliminate 7 from either of these. This one could be a 6 or an 8, because, well, one of these two is 6 or 8 to add up to 1. And the 9 has to be in one of these two, and it's going to add up to, it's going to be 2, 4, 9 is the other pair. Let's see. Well, I can, before I continue with that, I'm just going to quickly mark some more squares that cannot be things traveled by the boat. I also know I can't have a 4 here because, no, I still can, because it could be 2, 3, 4. And then I would just have a 1 here and a 6, 8 pair here, and that wouldn't break, because 8. Alright, no, I can't have 4, because then that's what adds up to 9. Right, yeah. Because if I have a 4 and a 3, then it would be 2, 3, 4, and that would be 9, but that breaks this. So this is either 6 or 8 still. If this one goes here, then it could be 8 with a 1, 2, 4 pair here, or a 1 here, or a 2 here and a 1, 2, 3 here. So that is still possible. And I actually think, I know for a fact one of these is a 2. Because let's consider what happens if neither of them is a 2. Then this is going to be a 1, 3 pair, which indicates that this is that this square here is also included. So then these two would have to be consecutive, and these two would have to be consecutive. So one of them is going to be a 1, 2 pair, and the other one is going to be a 3 with a minimum of 2, which actually doesn't break thinking about it. So it barely actually stays afloat, that logic. Although, actually, I think I've determined something better I can do. Suppose what happens if we have a 7 here. Then this needs to be a 6, 2 pair, so 6, 7, and 2. But then 6 here implies that I need a 1, 2, 3 pair here. So that breaks, which means I can get that this is either 1 or 3. So I can't have a 6 actually, because then this one need to be a 1, 2, 3 triple. So I can get that, and it lit up for my second given digit, which is good. It means I haven't messed up anything serious yet. I also can't have a 3 next to a 2, because then I need a 10 in the third spot, so I can't have a 7 here. And, alright. Now then, I have 6 shown as a circle. This cell and river cells orthogonally adjacent to it have a difference of 2. So this cell and the cell below it, yeah, just the cell below it, because I already have determined the river can't go up here, have a difference of 2. That's not something I think I'm going to be able to use right now, but it is useful to know. And I already know one of these two is a 2 to make this a valid triple, which means that this one is a minimum of 4. And it can be a maximum of 5, because 5, 1, 2, 4, 1, 3, or 4, 1, 2, and 1. 1, 2, yeah, 1, 2, 1, and then a 4 here. Those are all valid possibilities. Okay, I know that these two are part of an arrow, so they can't be part of a river because of earlier given information, and the same thing can be said about those. Let's see. Okay. Now this is a 4 or 5, and no matter... Now if it's a 4... Well, since one of these is a 2, actually, I can determine that no matter what, this is going to be a 1-2 pair. Because if this was a 2-3 pair, then it would already be 5, and that would break, which means I get a 3 here, and a 7 up here, and then a 9 over here, and a 1 here. And now I also have the 5 and 8 information, which I will mark in a second, mainly because I can get 6 here and 4 here to complete the magic square, which is actually going to give me 5 here, a 1-2 pair there, and I can remove that as a possibility of being part of the river. And from 6, I know that's a 3 or a 7. Now then, since I've gotten all that done, let's actually look at 5 and 8 as information. There is a boat cell in the river orthogonally adjacent to here. The boat cell is consecutive to both its neighbors in the river cell, and the 5 cell is not a river cell. So there's going to be a cell that the river cell passes through twice. I also know that this cell is a river cell because of 2. So let's just mark that. Since it's not at the end, it has to branch out both sides. And I get that. So there's a boat cell in the river. So one of these 2 cells is also going to be a boat cell. And that cell is guaranteed to be orthogonally adjacent to both the ones next to it instead of just potential or consecutive to both the ones next to it. Could be this one. Could also be up here if the river goes up. And since I don't know, I'm not going to do that yet. I do know 5 isn't consecutive to 1 or 2, so this cell below has to be what it's consecutive to. And let's look at 8. Orthogonally adjacent cells to this must contain different digits. So all 4 of these must be unique, which means not a bunch yet, but it is, I guess, something to keep in mind for the future. Now I'll just scroll back up to 3 because realistically that's going to be where I want to look at next, potentially actually. Okay, because 6 I already got all the information out of it. Yeah, I already got all the information out of 6, so okay. There's a boat cell in the river, orthogonally adjacent to here. Boat cell is consecutive to both of its neighbors in the river cell. 5 cells are not river cells. Okay. Trying to determine if I can actually force this one not to be a boat. I don't think I can, unfortunately. So, yeah, I'm just gonna go back to... Let's see. I know there isn't a 4 in any of these, but I'm not sure how that helps. Okay, well, I do have a triple here I can actually mark, so I should probably do that. Let's see. Does 5 have any relation? No. No, 5 is not required to be orthogonally or consecutive. But, okay. I I know at least these two cells are part of an arrow, and the arrow could potentially continue on any number of ways. Yeah, I'm gonna need to probably stare at this for a little bit longer to get an idea as to what the goal is for where I want to proceed next. One cell, some arrows can't be in a river cell. Yeah, I already got that. Oh, it's digits on the arrow. Digits on arrow form a number which equals the sum of the digits on the river. Oh, so considering the fact that this is at least 3 long, we reach the question. Well, this has to be a circle then, because 45 times 9 doesn't even get into a 4-digit number, and you don't sum these digits. It's just a number, which means this has to be some multiple of 100 here, and 45 times 9 is going to be, let's see, it's just going to be 405, right? Because 45 times 10 is 450, subtract 45 and you get that, which would mean that the largest this number could be is 405, but I can't have 0 as a digit, so its actually maximum is 399, which means this is a 1 or a 3. Can this be 300? Or a number in the 300s? Considering that the maximum is 405, and yeah, I've decided I'm going to break out a calculator for this puzzle now, because it seems increasingly necessary, even though I'm pretty sure this is just going to be a 1. I don't want to guess, because that defeats the point of Fog of War puzzles. Anyways, this group up here sums up to 37. So 323 now is the largest this number can get. But I can also remove this, which is 6. That brings it down to 317. These 3 sum up to a minimum of 6. These 2 sum up to a minimum of 3. And that puts me at 308. Then I also have these 2, which are going, now that I'm at 308 actually, and since I know 0 isn't a digit, I can actually conclude this has to be a 1 via just purely brute forcing the numbers, and there we go. Now I have a 4-1, which is the end of the river. The start and end of the river is in a 1-2 or 1-4 ratio to each other. And now that I know this is the end of the river, and it seems pretty clear that this, well, I can actually just show that if this goes down, then I can never reach here, so it must not go down. And I can't go down here for the same reason, so we get that, and then this, and that lets me conclude the shape of the river here. So one of these 2 is a boat, and I don't know which. Okay. And there's not a reasonable chance of me being able to conclude any information about these 2 numbers, so, okay. I'm either in a 1-2 or a 1-4 ratio of the other end of the river, which is over here. I know that this is a 1 or a 2, which means this must be a 1, 2, 4, or 8, but 1 is here, so this is a 2, a 4, or an 8. And okay. None of these 4 can be repeats. Alright. So this is either a, well, considering how much river there is between these, I think it is realistic to say that this is going to be a 2-digit number, and not a 3. Although there's no guarantee. It could be some arrow shape like that, with this being the head, in which case it would actually work out fine. Okay. Where do I want to go next with this now? That's the question. I know one of these 3 is a 9, I guess I'll pencil mark that while I'm spinning the wheels in my head, I guess. Okay, well, I know that since this is the end, this has to be adjacent to the end, or a consecutive number, so it can't be a 2, it has to be a 3, or a 7, because it can't be a 1 or a 5 or a 9 because of these 3, so this is 3 or 7. Which means, can this still be a boat? It can not. Yeah, it can't. First of all, consider this is a 6. Then this has to be 3, which actually it's just consecutive, so I can already determine, yeah, it actually could. For some reason I was going with the sum of them instead of just it being consecutive to both. So if this was to be a boat, it would be a 6 here, 5 here, and a 7 here, which is possible if this is a 7 and this is an 8. So it is still completely possible, actually, for that to be a boat. Anyways, this is a 2, 4, 8, and here's a 4, 6, 8. Just pencil marking those in since I have a 3, 7 pair here. Also, that can't be a 4 because of the 8 clue from here. So this is either 120 something or 180 something for the total sum. And which of the two it is still completely a mystery. Well, let's see. If this is a 9, then this one's guaranteed to be a boat. But since this is a 9, I need to have an 8 here. Which means I need to have a 7 here and a 6 here. So, right, because it can't go back up to 9, and they both have to be consecutive. So, okay. 9, 8, 7, 6. I don't see a reason why that wouldn't work. Or at least I don't currently see a reason why that breaks anything. Let's consider if this is, Yeah, no, I don't see a reason currently why that would break it. So, let's see. Okay. Trying to think of a way to proceed here in a reasonable amount of time without having to do an unreasonably large number of computations. Orthogonally adjacent cells to this must contain different digits. That's not going to help me because that just tells me I don't have a 4 here currently. And whatever this is also won't be able to be here. That's the only information it gives me. If I have a 7 here, then... Oh, that's it. If I have a 7 here, it breaks. I can determine that right now. Right, because if I have a 7 here, then this is 3, so this 7 has to be adjacent to this one. There's 2 numbers it could be. If it's 8, then this has to be a 7 and a boat. Mainly it has to be a boat, which means it must be a 7, and that breaks because I have a 7 here. If this is a 6, then once again this has to be the boat. But it can't be 6, 5, 4 because then that breaks that, so it has to be 6, 7, 8, and the 7 breaks again. So this can't be 7. If this is a 9, then I have a 7 here. And this is a 6, I have a 7 here. So this one's either a 6 or 9 as well, which makes this a 7. And I also got to determine that wasn't 7 way earlier because of the treble. But anyways, now I know that this one is a boat, so I'm going to mark it for that. And let's see. If this is 9, this has to be 8, 7, 6. And if this is a 6, then this is either 5 or 7. Hang on, I'll just mark this 7 real quick. And yeah. And then this has to be either 7, 8, 9. Well, the 7, 8, 9 one doesn't work because there's a 9 there, so it has to be 5 here. 4 and 3. Okay. So I've got my 2 possible combinations now for that. Okay. And this either has to be a 2 or a 4. Just because it has to be adjacent to this, or consecutive with this. Okay. And we actually know this can't be a 4 because of here. So it's a 7, and then it's an 8 and a 6, and then this one here is a 9, and there we go. I will get rid of that marking. I get a 4 here then. And now this is going to be, let's see, I currently have 12 here. And this has to be at 2 minimum, which means I need to have 21 because at least 21 and maximum of 21, since 12 plus 9 is the largest you can get out of these 5, and that is 21. So there we go. There's both of those. I can get rid of a 9 here. And let's see. I have another sum like this. Both of those are dead ends, so the river can't pass through them, which means the river is forced to go down here. And this sum is of this river digit the whole way around to over. Well, it's going to be whatever the river is connecting these two. And well, it has to be 2 digits since it can't have a 1, so that means these digits through here must be enough to get it from 2 digits to 3 digits. So let's assume that this is the largest it can possibly be, which would be 99, since these two are not separate things. And since I already know that these sum up to 10, 27, 33, the largest sum I can get is 41. So no matter what, that's obviously not going to be enough to bring this to 180 something. So now I get both of those, which, since this is a 4, I can't actually determine what number is there yet, because it could be 2 times 2 equals 4, or 1 times 4 equals 4. And I now know that this is going to be either 128 or 158. Anyways, this sum here is now, well, these 4 sum, so it's going to be 37 for these, plus whatever this is, will increase me from a 2 digit to whatever is going on here. So 37 plus a minimum of 3 means 40, which means this is a maximum of 8. And since this is a maximum of 45, right? Yeah, 37 plus 8, 45. That means, and this one here is a minimum of 125. This one is a minimum of 80. So it just has to have an 8. And minimum of 80. If this adds up to the smallest possible value of 40, it could be a maximum of 88, so maximum of 87, and minimum of 83 because of given digits here. So okay, now I have that information. This is a 37, and let's see, 37 plus 80 something plus a mystery number will get me to either 125 or 128. If this is 87, then this one has to be 40. Well, then this group here has to be 41, right? I'm also going to just, well, I can't do meaningless pencil marks, so I'll just do a 37 there so I don't have to keep re-adding this in my head. If this is 87, then this one would have to be a 4 to put it at 41. That breaks, so this can't be 87. If this is 85, then I could be adding 40 to it to get to 125, or I could be adding 43 to it. Well, I can't add 43 to it because then I would need to be a 6. This is 84, I have to be adding 41, which breaks because of the 4 here, or I could be adding 44, which will be a 7, and if this is 83, then I am adding either 42, which is going to be a 5, or I am adding 45, which is an 8. The 8 one actually breaks, so here we go. I have, now I can get rid of that. I have 3 possible digits here, each one corresponding to one of these 3. So, let's see. Where do I want to go next? Well, I know one of these two has to be an 8, and since I have an 8 here, this has to be an 8 for the river to continue. And I get another boat square, because it's another 5. And since it says orthogonally adjacent to both of its neighbors, I know that the boat it's talking about must be on this cell, which also has to be a river cell. Now then I get a 7 here and a 6 here. And I can keep pencil marking this boat down the river. And okay. Now then, this sum has to be in the 80s, so I need to determine how much this is extended. So I have 8 here, I have 30 here, so I have 42 already, just from this. And to get through here is going to be minimum of another 10, plus 6, so minimum of 58, so I can actually extend further out this way, which was something I hoped wouldn't be the case, but it is the case, so I can't do anything about that. This one's just 3. And I have a 4-9 pair here. I have 1 in one of these two. This is a 2-3-5 triple, and this is a 1-2-3-5 quadruple, but that one can't be 3 or 5. So that's 1 or 2 here. Additionally, I can mark an 8 in one of those, a 6 in one of these. Okay. Let's see. I know that there's a 7 in one of these too, I guess. Additionally, there's a 6 in one of these too. And there's a 4 somewhere in this box, and in one of these two. That box I'm not going to mark because it's a bit too many givens for me, or it's a bit too much freedom to actually lock in anything. I do have a 3, 5, or 9 here, and here a 2, 3, 5, or 9. Okay. 1, 2, 3, 1, 3, 4, 5, 6 are the possibilities here, which is not good enough yet for me. Anyways, I have this boat done, so I guess I'll actually leave them in here, just in case I made an error later. I can see why I have this information here. Okay. I have already used all of the usable information from all of this, I believe. Yeah, I have, okay. And there wasn't anything about restrictions on arrows other than that. Okay. Yep. Alright, I guess at this point I have to go back to trying to brute force out the shape of the river. Can I go all the way back here? My gut says no. Well, let's see. So these 3 are going to add, well, these 4 are going to add up to 10, 20, 26, 36, plus whatever is in these. This area is going to be, whatever, it's always going to be 842. So I'll just mark it up there. So then this was 10, 20, 30, 36. So if we have 36 plus 42, that's actually, wow, that's still solvable. I did not expect that. I really didn't expect that one to work. I'll leave the pointless pencil marking for that in there. But, okay. Well then, if that's valid, then pretty much any square can actually get reached by boat, other than maybe this corner one here. Because if this corner one gets reached, then all 5 of these are required, and if I want to minimize the sum, I would have to take an upper root here, go through these and these. And that's 10, 20, 35, 45, plus 42, 87. That's not valid, actually, so this square specifically is not in the boat path, because it would make it just too long. Okay. Well, I know there's actually 1 in one of these two, because, yeah, I missed that pencil marking earlier, since that one seems a little useful, potentially. There's also a 1 in this column, and a 2 in this column. Okay. This column here is 1, 2, 6, 8. Where do I want to look next? Is the question, because I don't think me brute forcing other scores that potentially both cannot reach is that fruitful. Especially since I'm pretty sure at this point, yeah, unless maybe no, this I think could be potentially large enough. 15, 30, 40, 82, yeah, okay. So that's, I can pretty much hit any square now with the river, and it will still be valid, which means I think I need to change strategy to looking for other things potentially. I say that, but I'm not really sure what I want to look for instead. Okay, I've already done. I've used all the information from these. And just to check, yeah, the river is a 1 to 2 ratio or a 1 to 4 ratio, which means I don't actually get to know which ratio it is. If this is a 3, actually, then this has to be a 4 or a 2, which breaks. Because 4 and 2 are both already locked in there, so this is a 5. Which means that this group here sums up to 42. Which means this has to be either a 3 or a 6, but 6 isn't possible down here, so it's okay. So I messed. Okay, so yeah, I did mess that up just immediately right off the bat. How did I get that so wrong? Did I lose a digit that used to be in here? I'm gonna jump back a lot real quick to when I was pencil marking these in, because I should have actually 3 digits in here. When was I calculating that? I'll jump back in a second. Okay. So I don't know, I guess I'm gonna have to redo some math real quick, because 3 clearly was not the correct answer. Just give me a second to jump back. Okay. Oh no, well, 5 was the right, so that deduction was correct. But the number down here was incorrect. So let me resum these. 30, that's gonna be now guaranteed to be, let's see, 7, 37, 42. So 42 additional to this, which would mean it needs, I feel like it would need to be a 3, right? Because 83 plus 42 gets me to 125. And it would need to be 86 plus 42 to get me to 128. Yeah, I feel like it was forced, but then I had just done 3 and it clearly isn't the right answer, 83. Well, now I know for a fact at least 12, 18, 6, 30, 40, yeah, 4. No, not 42. Oh, it's because there's a 4 here. That 4 I shouldn't be including. So this is actually 38. Which means 38, I could have theoretically, well, I couldn't have had 7 because of that, so all of the logic I've done, other than potentially brute forcing a 5 in here, should be valid actually, so let me see, I'm going to just re-go through the numbers again just to be sure, because I can't have a 7 here, and it would have needed to be in the 70 range, so it's still in the 80 range, and it's still a, could I even potentially hit 7 actually? These ones add up to 33, and I need to hit either, well, 33 here, and this one can be 3, 5, or 6. Well, actually it has to be 3 or 5. So 36 would mean I would need an 89, right? Because 125 minus 36 gets me to 89, and that's not possible. No, that is possible. 89 is possible. And let's see, if this is a 5, then I would have 41, which would mean I would need to hit either 84 or 87. So 84 is the other possibility. So, and there we go. This is my updated 2 possibilities. So it's 84 or 89 here. I already know which one it is because I messed up, but we're going to just try and find it logically because I had errors in my logic earlier. So if this is a, well, this can't be a 3 because of the logic given earlier, so and here we go. So now I know that this group here sums up to 38, which means that this has to be a 5. And 38, let's see, this minus 38 is going to get me 125 minus 38 gets me what? That gets me needing 87. So there we go. I don't know where all my random numbers for this were coming from my head, but now I do have a number locked in, so I'll take it. And here we have a 7 cell, which must be part of the river. So now that I know that, what information does that give me, actually? That's, because clearly this is supposed to be the information that, or information that helps solve the puzzle definitively. I'm not particularly sure what information I get from this right now. That's a, well, this one actually here can be only 4, so I can get that. I have 3 or 9 here, and this is a 7. Which means one of these, well, this one can't be 6 or 8, so then the next one must be here, which must be an 8 because 6 already sees here. So I get that, and then this. And I can eliminate all of these and these 2 from being part of the river, because it would have to cross over itself to hit, reach any of those. Okay, one of these 2 is a 7. For the river here, I think, well, this is a 6 or an 8. It has to go straight through. No, it doesn't actually have to go straight through, because it could go up for one and then horizontal for the other. Well, I know this here is a pair of 4 and 5. And this here is going to be a triple of 2, 6, and 9, and then this is a 1, 3 pair. And I need to regain that pencil marking there real quick. Okay. So if I go down here, then I have to go horizontally across to this 2 here. And then I could either go across to a 4, which would have to go down to a 5, or I'd have to go to a 6 that goes down to a 5. So either way, this square would get hit. Just because I can't make a possible pathway that doesn't do this. And actually, I couldn't go, I would have to go like this, and then here. If I went down here, yeah. This is how it would have to be, I believe. No, this could be a 5 and then here. So let me mark my possibilities. If I go down here, then I have to go over to a 2, and then I can either go across to 4 and then a 6 here, or I can go, let's see, this color down here to a 6 and then a 5 here, and then I can't go up because I'll cross over myself, so I have to go here first and then here. In which case this is 1, 2, or 6. Can I get an 8? Theoretically, if this is a 7 or a 9, yes. Well, let's see. Then the other option is that I go over this way, in which case I'm going to have to enter here, down here, and then I can't go up again, and I can't go up again, so I get that, and then well, if this is a 1 or a 3, then I need to have a 2, 4, and one of these 2. This could be a 4, or this can be a 2. Okay, I could still go in either direction here. I don't see a reason why I couldn't. So I'm going to actually scrap the possibilities since I'm not actually getting any information out of them right now. It might be more useful for me just to do more pencil marking then. 1, 3, 6. Okay, that's a 6. And then I have a 2, 5, 9, 2, 4, 5, 9. Quadruple for the remaining cells. Okay. If this cell is up here is water, then I can guarantee a shape like this. I don't think that actually helps that much. So I am going to scrap that. I'm not sure if actually trying to figure out the river shape right now helps really much at all. Yeah, that might be my concern here. Is that what I'm actually supposed to do is something completely different. Here I also have 2, 4, 5, and then 2, 4, 5, 7. I'm not sure what I want to do now. Okay. The real challenge I'm running into here is that it seems perfectly possible for me to just have a straight line here, but at the same time also just have a straight path going here. And I'm not particularly sure how I should differentiate between those. Either way, this is a sum of 42 here. These two add to 15. Okay, I might have to actually use logic on the size of the sum now. Okay, so these add up to 15. So that means I currently then have 57 is my sum of everything, and these remaining ones then need to add up to 30 exactly. Let's consider if I go back here, then I already have 15 here, and then I get a minimum of 7 here, which is 22, and I have another 15 here. Or I have 10 here and 5 here, so 15 either way, which means I can't hit this back row, because the numbers wouldn't add up. So now I am going to remake the pathways, since I have now been actually restricted down to 3 potential ones. Or, well, 4, because it could be either those cells. So actually, I'm once again going to remove them because I hadn't considered that. Let's see, if I have these 3, then the minimum they can sum up to is 1, 4, and 8. Well, I actually can't have a 1 in any of them, so it has to be 3, 4, and 8 if I go this way. And I don't have a place I could place an 8, so I actually can't go over here, because there is an 8 required, but there is also nothing in either of any of these cells that are adjacent to an 8 possible, other than 9. So let me quickly uncolor that and consider the 9 case. In which case I have a 9 here and an 8 here. And then I have a okay. Yeah, this is also going to break. Because I have 9 and 8, right, but now I need 1, 3, or 4 here to connect to here. And I would say 4, but since I have a 9 and 1 in here, this is already 4, so it's actually only a 1 or a 3. And that does truly break it. Which means I have 1, 3 here, and then I go here and have a 2. And this should, clear the fog. Which means I did not make a mistake again. So that's good to see. Now I can go 6, 5, 1 or 2, 1. That's one possibility to go down here, 6, 5, 2, 1. Or 5, 6. So this can't be an 8 now. So I actually know that this is an 8, which tells me that the correct pathway is this one, since this one down here requires me to have a 2 here. Okay. Then I have an 8 over here. Then I know I have a 5 here and a 6 here, which means I have a 4 here, and I can do some pencil mark removal. And I have a 6 here, which means this cell and the river cells orthogonally adjacent to it have a difference of 2. Which means this can't be part of a river. Which means this isn't a part of a river, and this isn't part of a river. Because if this was part of the river, then it couldn't be consecutive to any cells next to it, which is the thing that's most important to know about that. And rivers do need to be consecutive to something at least next to them, so that's why that one's eliminated. Okay. Now then, I had up here a sum of 42 plus 15 gets me to 57. So I'm gonna mark that over here. And now I can add in another 13, which is going to get me to 70. So I need these last 4 to add up to 17. Which means I need this group of 3 to either be 14 or 16, depending on what this is. If I have a... I can't go up here then, can I? Because then I would need to have a 2 here. 2 plus 3 is the largest this can be, which would already require this to be a 9 to get up to just 14. So I can't go up here, which means I have to go over. And then I have, I have 3 cells here to be 14 or 16. Okay. Can I do this without 9? Then I need to be 7, 5, 4 is the maximum, which is 16. So yeah, I don't need 9 necessarily in this. And I know that this cell has to be 2 off of the cell below it as well. I'm not sure if this is where, well, one of these two is a 7, which means the other one needs to be 2 up. The other one of these two cells needs to be 2 off of a 7, which means this is a 7 or 9, this is a 5, 7 or 9. Okay. So then, let's see. Where do I go from here? 30, 38, 42, 57, 68, 70, minimum 77, minimum 78. These two are a maximum of 9, which this one and whatever is next to it makes a maximum of 9. And a minimum of, if this is a, I can increase each of these by 2, minimum of 5. So 5, 7, or 9 is the sum of the 2 cells on the way over here. If it's 5, it would have to be 2, 3 for them to be adjacent to each other, which doesn't work because 9 would have to be adjacent to an 8 anyways. So thinking about it, that's just impossible, so I don't even need to concern myself with that case. And, oh, I guess now that I've revealed those, apparently this is supposed to be classic Sudoku, but it's not quite that yet, because I must have not deduced everything they expected me to deduce before revealing that. Well, okay. Alright. Where do I want to look next, then? Or what do I want to think about now? Because I think it really does need to be finishing up this river. So I have, this group here is 42. That makes it 57. 68, 70, 77. Which means I need these last 3 to add up to 10. So if I go here, then these two need to be 1 and 3, and this one need to be a 6, which is impossible. So I have to go up here. And then these two are either going to add up to 9 or 7. If they add up to 7, it can't be 1, 6, it has to be 2, 5, or 3, 4. So it would have to be 3, 4, because 2, 5 wouldn't let anything be consecutive to the 2. So this is either 3, 4, well, one of these two is 4, just guaranteed, or it's going to be, if this is, well, 3, 4, 3, or this is a 1, then it's 1, 4, 5, which means I get that. And both of those work because 4 and 5 are consecutive and 3 and 4 are consecutive. Okay. Well, this has to be a 1 actually then. No, it doesn't actually have to be a 1. I lied, because this could be a 1 in the column, and I missed that square. But this does have to be a 4. So I can mark that in. Okay. Well, now it is just, well, it's almost classic Sudoku. Not quite still, because this digit here will inform me what these two are. So if I have a 3 here, then I have a 3 up here, and one of these two is a 3. If I have a 1 here, then I have a 5 up here, and one of these two is a 5. Well, this is actually just a 7. So this would be a 5 in that case. Which would make that a 5? Yeah. Okay. And in the case of this is a 3-4, can I determine anything about where the 5 ends up? That's an angle of attack I could go for. I don't think it works, actually. Thinking about it. Yeah, I don't think that's what I want to do, because I could have a 5 here, or here, or here. So that doesn't actually narrow things down at all. I already have all the 8s in the grid. One of these two is a 6. Okay, that's... I have all the 6s now pencil marked. Well, one of these two is actually a 9, so this isn't a 9 and this is a 9, which makes this a 5, which actually means now I will truly be in just classic Sudoku, because I determined this was 3-4, which makes this a 3. And yeah, now I am solving just classic Sudoku, which means it should go a lot smoother since I don't have to actually look for any non-obvious logic. So I can just get all the numbers in. And yeah. So I will say this while I'm finishing up the solve here, especially since this video has been going on long. I really like that puzzle. It's definitely a lot more difficult than any of the other Fog of Wars I've done, other than, well, there was one, but yeah, one other one I've done on the channel that was of a similar-ish difficulty level. But I did really enjoy this one, and I'm definitely gonna plan on doing more of these in the future, especially since this was a solve path that, well, a kind of Sudoku solve I've never had to really do before, and those are the kind of ones I really like. So if you liked this and somehow made it through the over hour of solving, then you probably would like to solve some of these yourself. So yeah, just go check the description. I'll have a couple links in there, one to this person's Logic Masters Germany page, and another one just to this Sudoku, I guess. But yeah, anyways, I'll see you all next time I see you all, and if you're still here, thanks for sticking through the long video. Bye.